Hello everyone and welcome back. Today we're going to have a bit of a tutorial on how to decide in an election using preferential ballots and a Borda count. So we have the same randomly generated election that we had last time when we were talking about instant runoff elections. And so we have the same three candidates, Ned, Olive, and Peter, the same 100 voters, and the same ballots that they've cast. We're just going to evaluate them in a different way. We're going to decide this using a Borda count. So what does that mean? Well, a Borda count is a system whereby we assign points to each ballot, for each ballot to each candidate, and then we add up those points, and whoever gets the most points wins. So let's take a look at how that goes. So before we can do that, we need to decide a scheme. If you were an election official, you would definitely want to decide the point scheme beforehand. Otherwise, people are going to cry foul, because it turns out that sometimes if you change the point scheme, you can change the outcome of the election. Yikes. So in any case, let's go with the simple one here. We're just going to award, because there are three candidates, we'll give 3 points for first place, 2 points for second place, and 1 point for third place. And we're going to just calculate now. So what I've done is I've set up a bit of a table here, and I'm going to say for each type of ballot, how many points each candidate gets. So for example, for a ballot of the type NPO, so Ned over Olive over Peter, for that kind of ballot, Ned is going to get 3 points because he's in first place, right? And then Olive will get 2 points for that ballot, and Peter will get 1 point for that ballot. Every candidate gets some number of points for every ballot, even if they're in last place. So since there are 11 ballots of this type, Ned will get 11 times 3. 3 points for each ballot, 11 ballots, for a total of 33. Olive will get 2 points for each for a total of 22, and Peter will get 1 point for each for a total of 11. So let's take a look at one that's in a slightly different order. For example, down here at OPN, in this case, Olive will get 3 for each, Peter will get 2 for each, and Ned will get 1 for each. So Ned gets 1 point for each ballot. There are 22 ballots, so he gets 1 times 22 is 22. Olive is in first place on all of these ballots, so she gets 3 points for each, so 22 times 3 is 66. And Peter gets 22 times 2 for his second place in each of those ballots. We go down the line and we figure this out for every single type of ballot, so every ballot is counted and results in points for each candidate. So there we have it. We just add up the totals down the columns, and that gives us a point count for each candidate. We have 183 points for Ned, 212 points for Olive, and 205 points for Peter. One way that you can check if you've done this calculation correctly, or at least hopefully so, is to look at how many points there are for each ballot. Each ballot has a 3 point, a 2 point, and a 1 point. So there's 6 points for each ballot. And we had 100 candidates. So that should mean that there are a total of 600 points available. And indeed, if you add these up, you do get 600. So we haven't missed anything in our calculations. And it's always nice to have a little bit of a check at the end. In any case, by the Borda count, Olive has 212 points. It's close again, but she is clearly the winner. If there had been even more candidates than just 3, then we would extend this system and award points in a different way. So, for example, we might give 4 points for first, 3 points for second, etc. Or there are other ways that you can do it. As I said, there's one country that does 1 point for first, half a point for second, a third of a point for third, and so on. It gets a little bit complicated calculating it that way, but it works. However you decide to set it up is fine. All of these systems are subject to the same problems of Arrow's theorem, that you're going to run into paradoxical situations with a preferential ballot system. There's just no way around it without having a system that doesn't make sense at all. So that's